Okay, let's look at Theorem 2, midpoint connector theorem for trapezoids. Right? So let's say M is the midpoint of segment AD, right? Then if MN, N is the point between B and C, so MN is parallel to AB, which is automatically parallel to segment DC, then N is the midpoint, so N is automatically the midpoint of BC, so midpoint of BC. And so let's see, we want to say these are congruent, so we don't know that yet, we have to establish that. Then also the length MN is basically the average of AB and DC. Right, so let's prove that. I'm gonna give you a picture proof. Right, so here's the construction. So we're gonna draw a diagonal here, diagonal AC. Right, so I'm gonna draw a diagonal AC like that. Right, the motivation for this is that we can use the midpoint connector theorem for triangles. So let's call this point say L. Right. So by the corollary of the midpoint connector theorem for a triangle, M is the midpoint and the ML is parallel to DC, then L is going to be the midpoint of AC. So we already know that, let's see, this is congruent to this guy, right? L is the midpoint, right? And we know that the LN is parallel to AB, and we already established that the L is the midpoint by, again, the corollary of midpoint connector theorem for triangle. We know that the N is the midpoint, so we already have that, right? So we already established that. So basically we just apply corollary of a midpoint connector theorem for triangles twice to get to conclude that, right? Then again, if you look at this triangle, right? So the ML is a midpoint connector. So this is going to have the length 1/2 of DC, right? And the LN is also a midpoint connector of this triangle ABC. So therefore, this guy is half the length of AB. Right, so therefore MN is just the sum of these two. So that's why you get the 1/2 AB, which is from here, and a 1/2 DC, which is from here. Right, so that will verify this guy. Right, so let's look at its converse statement. Right, so conversely, right, N is the midpoint. So this is the hypothesis. So N is already a midpoint. Then we know that MN is going to be parallel to AB, or DC, same thing. And MN is length the same way. Right, so here's what's given. So we already know that M is the midpoint, N is the midpoint. Right, then we're going to do, let's see, so we want to do same kind of deal. Right, if this is the MN, if MN is not parallel to AB, let's argue that. So let's assume, for the sake of argument, MN is not parallel, right? So if MN is not parallel to AB, we can find the parallel one, different one. So I'm gonna find the segment M, say N prime. N prime, so that AB and the segment M N prime are parallel to each other, right? But let's see, if they are parallel, then we know that by this theorem we just established, N prime is the midpoint, right? So this guy is going to be a midpoint. Oops. So N prime, I'll just say this guy. Oops. Right, sorry about that. So n prime, so this guy must be the midpoint of segment BC, right? Which is actually a contradiction, because we said that n is the midpoint of BC, so you are having two different midpoints, right? So this is a contradiction. So therefore, we have to have mn has to be parallel to segment AB, right? So that gives you that. And this equation is the same way. Once you have mn parallel to each other, then we can just do same kind of construction and connect A and C together. Then we know that this length right here is 1/2 of DC, and this length right here is 1/2 of AB. So just using the midpoint connector theorem for triangles twice to get that length there, right? That will establish that same equality there. Right? That's it. I hope that this was clear.